Hello friends, so again I am here with taking my new sessions for you, and previously we just completed a total 11 examples on the based on logarithmic functions, and today I am going to conduct next some examples for the similar method. So let's start with the part 1 only, and now let's start with the examples. And here I have written a 12th examples because already we practiced 11 examples. So see the next one. The question is given: separate the real and imaginary parts of the given functions. Okay, so I think now you all are aware from this method, because in 11th example we just found out the similar parts, yani ki real and imaginary parts. So I hope you will do with your own self, but then also I'm just giving little bit highlights. So if you couldn't understand properly, then you can understand very well today. So see, the equation is given. First one, log of 1 plus I base 1 minus I. Okay, so by using logarithmic rule, yani ki log A base B, then you can write log A upon log B, right? So same way I am applying log of 1 plus I upon log 1 minus I. Okay, and then after I hope you all know now that what is your next step, right? Because in the next step you have to apply either principal logarithm or as general, and as we have discussed before, that always you will mostly apply principal arguments only, right? So here I'm applying, you can see that x and y both are coming 1. So just applying its formula and giving the simplification, you will get this one. And here you can see that, guys, log 2 is coming, and root 2 yani ki 2 raised to 1 upon 2, and 1 upon 2 I am putting outside, so 1 half log 2, same as here. Okay, now you can observe, guys, in the denominator I is coming, which is not valid anytime. Okay, so to remove this I, you have to apply its conjugate, you have to multiply it with by its conjugate. ओके, conjugate यानी कि अगर हम लोग गुजराती में बोले तो उसको करनी बोलते हैं, करनी. ओके, सो यहाँ पे आपको उसकी करनी अप्लाई करनी है, राइट? सो with the same component I have applied with the positive sign. Here it's given a negative sign, then I will apply it with positive signs. So multiplying this term in numerator as well as in denominator. So now just giving the multiplication, you will get this one term as I have written here, and this one you have to do with your own self, guys, because it's just a simplification, it's just a multiplication. And then after you have to just separate the terms in the real numbers as well as in the imaginary. Real में I नहीं आएगा, and in the imaginary parts the I will be includes. Okay, I mean the coefficients of I will be its imaginary parts. Okay, and same here is given next one, the 12th of second example of the 12th example, and it's given 1 plus I whole raised to I. So in the very first step, applying log on both the sides, and then after giving the simplification you will get this one. This one is very much easy example, guys, so it's all are repeating and you know very well now. So just giving the simplification and you will get this final real number as well as imaginary number. Imaginary yani ki the coefficients of I, that will be imaginary part. And this one also examples you have to do with your own self now, because these all the examples are very easiest now, because you all know we did so many examples till this session. Now here it's given a 14th example, there is no 13th example, directly I am writing 14. Okay, and the question is given: If sine of alpha plus ib equals to x plus iy, then prove that the first one is given x square upon cos h square beta plus y square upon sin h square beta equals to 1. ओके इसके जैसे आई थिंक दो और तीन और एग्जांपल्स है गाइस, but one I am going to do because based on this you will solve another examples. Okay, so see here I have written two formulas of circular and the hyperbolic function. It's a given actual relation between hyperbolic and the circular function, and this one formula we have already applied in the example number, I think it was fifth or sixth example, right? So this one I have written as a notes also. And now see, we are going to start this example, and in the question is given sine of alpha plus ib equals to x plus iy. Okay, now first of all you know the values of sine of alpha plus beta, because this one we have already studied in the 11th 12th standard. So hope you all might be aware. So I'm just splitting this formula. So sine alpha cos h beta, because this one is a rule of circular to hyperbolic. Okay, because actually it will be sine I beta, and in place of sine I beta we can write this one. Okay, so first of all I'm writing its formula, that sine cos plus cos sine, this one is actual formula of this one. So I'm writing here sine alpha into cos I beta plus cos alpha into the sine I beta. Okay, and in place of this sine alpha I am keeping as it is, cos I beta, in place of this we can write this cos h beta. So I have written here cos h beta, and here we are getting cos alpha into this sine I beta, and in place of sine I beta we can apply I sine h beta. So here I have written I sine h beta. Okay, so now I hope you all understood, guys. See, first of all I have simplified the bracket as a sine of alpha plus beta, yani ki sine into cos plus cos into the sine. So this one I have written here in the this third step, and in the between this one is came from this third to second one. Okay, now I'm just writing imaginary and equating the terms, real as well as imaginary parts, so that you can compare it with this one. So x equals to, we can write sin alpha into cos h beta, and y equals to, it will be cos alpha into the sin h beta. And here I am going to make a subject of sin and here of cos. Because why I have made a subject of this alpha only? Because you can see the first condition over here, this one. Here you can see the equation is given into the form of beta. It means you need the answer in the rest of the given component, and the question has been asked into the beta form. It means accept the beta, it's the answer will be okay. So that's why I have made a subject of alpha, and here sin alpha and here cos alpha. Okay, so making a subject of sin alpha, it will be x upon cos h beta, and making a subject of cos alpha, it will be y upon sin h beta. And now we know the one identity for sin and cos is the sin square plus cos square alpha equals to 1. Okay, I hope this identity you know all very well. Now next. Okay, I'm just applying the values of sin and cos. because already we have found the values of sin alpha and cos alpha. So just putting these values, you can get this answer finally. And now the second condition is given, x square upon sin square alpha minus y square upon cos square alpha equals to 1. This one you are going to prove now. Okay. So for that you can see the question. There is given, the question has been asked in the form of alpha. I'm highlighting, guys. See here. You can see the question has been asked into the form of alpha. It means the answer, the solution of this question must be in the form of beta, right? So of course we will make a subject of here beta function. So in from our previous slide we will make a subject of beta, yani ki cos h beta as well as sin h beta. So I'm just making a subject of this both, then it is being x upon sin alpha and here it is being y upon cos alpha. Okay, now here cos h beta, this is your hyperbolic function. I hope you all know very well, guys, because in the first and second semester we already did this hyperbolic function. So here I have written identity for the hyperbolic function. Guys, I am highlighting so that you can understand very well this one. This one is identity of hyperbolic. So here it will be sin h square beta minus cos h square beta minus sin h square beta equals to 1. And this is equation, this is the formula, this is the identity of hyperbolic function. यहाँ पे बीच में प्लस नहीं आएगा. Okay. So at the last, putting the values of this, you will get the final answer as an x square upon sin square minus y square upon cos square equals to 1. So this example was little bit different from the others, and now I am going to complete this method, and there are some sums regarding based on this method, and that I'll do in the assignment so that you can do more practice. So in our next session we will start one more new method. So till that, please do this all the practice, guys, so that next methods will be easiest for you. Thank you. See you soon in our next session. Thank you.